Welcome you all for this video. This is regarding to find the complex envelope of the signal. So before that, let us find what is the low pass signal frequency spectrum and how it can be how it can be applied the Hilbert transform to extract the pre-envelope of the signal. So let us discuss on that, and later we can go for the another envelope extracting, that is complex envelope extracting. So let me consider first as a low pass signal frequency spectrum. So first I will write the first as a low pass signal, low pass signal frequency spectrum. So first I am considering a low pass signal frequency spectrum. Okay. So now what is a low? So this is going to be the low pass frequency spectrum. This is exactly looking like the spectrum of LPF, that is the low pass filter. Okay, so low pass signal. So this is what the spectrum look like. So minus W2 plus W and having the magnitude at 0. Magnitude at F component is going to be equal to 0. This is a G of F, that is the low pass signal. So we are applying after Hilbert transform. So what this becomes? This becomes that is, what is the formula to apply the Hilbert transform? That is G cap of F is equal to minus J signum of F into G of F. So after applying this formula, so we can write the spectrum as, okay, we can write the spectrum as, so this is going to be minus W, that is the spectrum of minus J signum of F will give the negative. For the negative frequencies, it is positive components. For positive frequency, you will get it as the negative component. So this is for positive frequency. So this is G of 0 and this is minus G of 0. So this is the response for G cap of F. That is what after taking the Hilbert transform. So now to extract the frequency envelope of this signal. Now to extract the frequency envelope of the signal. So after applying the frequency envelope, pre-envelope. So pre-envelope of the signal. Pre-envelope of the signal, that is, so G plus of t is equal to 2 times of 0 to infinity, only positive frequency we are considering, G of f into the exponential term j 2 pi f dt into df. So when you convert this into a frequency domain, this becomes G plus of f is equal to G of f plus signum of G of f. So what is G plus of f? From this we can write it as, only for the positive component, it is G of f. So what is G in the time domain? That is the G plus of t can be written as G plus of t is equal to 2 times 0 to infinity G of f j e to the power of j 2 pi ft into df. Okay. So now we have to write the spectrum, frequency spectrum of this low pass signal. Now we are supposed to write the frequency spectrum, positive as well as for the negative. So we can also write the negative frequency spectrum as G minus of t is equal to 2 times of minus infinity to 0 G of f e to the power of minus j 2 pi ft into df. This is for negative frequency. So let me draw the spectrum here. So this is the spectrum. This look like for positive frequency. which is having the magnitude G 2 times of G of 0. So this is considered as the positive frequency G plus of F. Similarly, for the negative frequency, you can write it as, so this is going to be the negative frequency, that is G minus of F is equal to 2 times of G naught. Okay, so with the negative frequency, and this is 0. So this is the x-axis is varying with respect to the frequency. So this is about extracting the pre-envelope, and first we have the GF low pass signal, extracting the Hilbert transform. So later converting that into a pre-envelope of the signal. So both the signal extracting, that is the positive frequency component as well as the negative frequency component. Now is to find the next step is to find what is the complex envelope of the signal. So what is the complex envelope? So far we have discussed about the pre-envelope of the signal. So let us find now what is the complex envelope of the signal. So for that reason you can write. So the next topic is to find the complex envelope. Since the derivation is already done, so only we are going to concentrate on the problems. So complex envelope of the signal. So how they are related? That is x negation or the transpose of t is equal to x plus of t e to the power of minus j 2 pi fct. Just you have to shift the pre-envelope of the signal. So this can applicable for the negative frequency also. So when you take into a frequency domain, h transpose of f is equal to x of x pre-envelope of f plus fc. So this can be written as plus fc. Okay. So since we have considered there as a fc, so many frequencies you can consider. So next is to find the complex envelope of the signal. Next is to find the complex envelope of the signal. So for that reason, you can write the complex envelope. First example, first one is to find complex envelope of the signal, complex envelope of the signal. Okay, so that is x of t is equal to AC cos of 2 pi fct. From the earlier examples, we have found what is the pre-envelope of the signal. So let us write what is the pre-envelope? That is x plus of t is equal to AC e to the power of j 2 pi fct. Now we have to shift it. That is what the x tilde of t. So or x transpose of t. So what I do, I'm going to shift this. So this we have the x tilde x plus of t, that is getting multiplied with e to the power of minus j 2 pi fct. So now after doing that, so x tilde of t is equal to, we have x of t, so that is multiplied with e to the power of minus j 2 pi fct. Okay, so now what is x tilde of t? After substituting what is the uh, pre-envelope of the signal, so we have the pre-envelope of the signal as AC e to the power of j 2 pi fct. So considering that, so we can write this as AC times e to the power of plus j 2 pi fct multiplied with e to the power of minus j 2 pi fct. So what is left out with, because this is the value of this is going to have the value 1. So x tilde of t is equal to only the magnitude of the carrier signal. Since C stands for the carrier signal, after extracting the complex envelope, the signal becomes only the magnitude of it. So this is going to be the complex envelope of a signal. Next, we take the next example. That is example 2. Example 2. The same example what we have considered earlier, that is S of t is equal to AC m of t cos of 2 pi fct cos of 2 pi fct. So S plus of t is equal to AC times m of t e to the power of j 2 pi fct, e to the power of j 2 pi fct. So that is going to be the pre-envelope of the signal. This is going to be the pre-envelope of the signal. We extracted earlier also, that is AC into m of t to the power of j 2 pi fct. So we are supposed to extract what is the complex envelope of this. So that is going to be equal to S plus of t into e to the power of minus j 2 pi fct. That is what we have to shift the signal. Okay. So when you're going to substitute S plus of t as AC m of t e to the power of j 2 pi fct into e to the power of minus j 2 pi fct. Okay. So now S tilde of t is going to have the value of AC m of t. So where we have considered the magnitude in case of natural envelope, but here we are considering only the magnitude of the only the amplitude of the signal. Okay, so this is about the second example. Let us consider, let me consider the third example of it. That is x of t is equal to, now this is for the example 3. That is x of t is equal to, x of t is equal to AC times cos of omega ct minus b sin omega ct, sin omega ct. Now what I do, I take the x of t signal, x of t, that is going to be cos and sin in terms of exponential. I'm going to write, that is a e to the power of j omega ct plus e to the power of minus j omega ct. Okay, so divided by 2, divided by 2 minus b times e to the power of minus plus j omega ct minus of minus j omega ct divided by 2j, divided by 2j. Now what is x of t? X plus of t. So x plus of t is equal to a e to the power of j omega ct minus b times of e to the power of j omega ct. Okay, so what I do, since it is the 2j, that is 2, this is b by j. So what I do, so I'm going to multiply it with the plus j as well as denominator as j and numerator with respect to j. So after multiplying and extracting, that is s plus of t is equal to a plus this when you multiplying my j, it becomes minus 1. So minus 1 into minus of this is sign of this minus becomes plus. So we can write, that is a plus AJB, A plus JB e to the power of j omega ct, e to the power of j omega ct. Now we have to extract the natural envelope of this. So after extracting the natural envelope, this is what the natural envelope, finding the natural envelope of the signal, that is equal to A plus J times B, the magnitude, that is equal to A square plus B square, that is equal to A square plus B square. Now x tilde of t is equal to A plus JB. Okay, so this is what the complex exponent transfer of t. Hope these are the problems regarding to find the complex envelope of the signal by extracting the pre-envelope. So hope this is going to be useful for you. Thank you for watching this video.